hope you are all aware how to create your own AWS account. So before that, I just want to take you through some of the important things on Docker. Let me show you the architecture first so that you will be getting an idea what is an architecture and how it would be and all those things. First of all, what is the use of Docker, exactly why we have to use this. So all these things comes into the picture. Then after that, we will learn about the Docker very quickly. So if you can see, this picture depicts about the here is a picture which shows you what is the Docker exactly. You know already in 20s and in the 20th decade, we used to deploy our applications on the top of the operating system directly. So basically, when you deploy your application to serve traffic on the top of the operating system, that would be fine. A single operating system can serve your application and it will available for the customer. So here is the one important thing is that there are some challenges for the people who are using traditional virtual machines. In this picture, in the right side, if you can see, in the right side of the picture, this picture is building multiple virtual machines on the top of the single operating system. So basically, this is the method which is used with the help of hypervisor. On the top of your operating system is nothing but you can consider your own Windows system or any other system. On the top of that, you will be installing hypervisor. Hypervisor is basically a software which is going to give you features of making your infrastructure as a resources for building the next operating systems on the top of the operating system. So in simple words, in a word statement, if I want to talk about the virtual machine concept on the local machine is nothing but building multiple virtual machines on a single system. The main advantage of this and main motto of creating multiple operating systems on the single operating system is to utilize system resources properly. So basically, if you can see in the picture, on the top of the hypervisor, an individual guest operating systems, whatever the operating systems you want to install, like CentOS or Ubuntu, or what are the even application requirement-wise operating systems were there, that operating systems will be installed on the top of this, and on the top of the one systems, you will be deploying your applications. Like you can see in the picture, application A is nothing but it related to some application, and next one is another application like that. So basically, this approach has been given a good system resource utilization method, but thing is that when there are many complexities have pending. In the complexities, the first one is system response. You can see the infrastructure which is provided by the operating system, which is a configuration, and the operating systems which are built on the top of the operating systems are becoming equal. Let us assume that is 8 CPU and 24 GB RAM. I'm giving for my operating system 3 operating system I'm taking, and for one I'm giving 3 GB and RAM 3 core processor, and for another system I'm giving 3 core processor. Let us assume I'm giving in that way. Because of this, what happened? 4 core I'm giving, and 2 core I'm giving. So if I give in that way, what happening is the systems are using maximum utilization. So if you can see here, this is 2 core, this is 2 core, this is 4 core. Actually, our system is 8 core. Now this is also 8 core. If I already give all the amount of CPU to here, how the original operating system will work? And if you leave even a 1 CPU or 2 CPU left for this, it would be very tough task to maintain entire this infrastructure on the simple infrastructure now. Is it going to be complex thing or not? The next one is, once you up the machines on the top of this operating. The second important point is the reboot time of a operating system is more than 2 hours, 1 hour, 3 hours, 4 hours. Means it may take 30 minutes, it may take 1 hour, it may take 3 hours of time, it may take 4 hours of time. You know, serving an application is not a small thing. Whenever you serve an application, basically it should be always up and running 24/7. That is a client requirement, right? If you are taking for one application to reboot it, if your application is down for 3 or 4 hours, what is the use of building an application for a higher hourly? So that is a problematic thing. So one more thing, which is a problematic thing, we have found here as a major problem. Okay, now next important thing is third one. What is the third important factor on the top of this one, Docker? First one is system response. Second one is rebooting time. And third one is network, which is a major issue. These operating systems are commonly connected through the network, but problem is if these are having any network issues, all the systems will go away from the network. When system goes down, when main server goes down, even there will be a network switches will be there, like we can say that network outages for a couple of seconds because of technical issues of the network ISPs, internet service providers. Any that kind of situation happens, automatically all the networks will become down. You know already, if the network is down, automatically application will be down. So there is no use of deploying it. So these many complexities have come into the picture. So they want to come up with a solution, what we can do for this. So what they done is, we need a one engine which can be installed as a tool on the top of the machine. And that tool is going to support all the applications on the top of it. And all the applications should be having a very lightweight images. And that should have served the application very quick span of time, and restarting time should be in a seconds of time. This is the application motto they want to design. So their design comes into the picture is called Docker. So how the Docker will work now? Very easy. This is an infrastructure same how we have used in the normal virtual machine. And next, the host operating system means whatever you have installed, like you install Windows or anything operating any operating system, Ubuntu or CentOS. Then on the top of that, we will be installing a tool called Docker. What this Docker does, basically, whenever you search in a Google, the Docker itself a symbol. You can see what is the meaning of this. You may see some example from this. Directly you can understand something. What it is doing, Docker is shipping some containers. Yes or no? Docker is actually a ship name. Basically what it does, it will ship some containers one location to other location. On the basis of this only the name given. Then what this will ship is, this also will ship the lightweight containers from one server to another server and repositories and across the globe everywhere. What is the main advantage of this? What is the main advantage of this? So when you install the Docker, here in the normal operating system, when you install in individual operating systems, every application have their own individual libraries and binary files. But when you install the Docker will consider system library and binary files and will share to all the applications in a common way. Means it will share for every application in a common way. Because of this, what happens? Your operating system will be not that much of burden mode, because it is not going to give any burden to your operating system infrastructure. But here already everything is considering directly. It is taking 2 core, it is taking 2 core, it is taking 4 core. Because of this, what happened? Even system is hanging. But here there is no problem. It will consider your entire library files for each and every application. And second important thing is the network will be very strong in maintaining and connecting to the applications. And third important thing is your operating system, main operating system volume will be used into a multiple divided volumes, which is logically attachable to all the applications. See how many advantages. Network issue cleared. system restart time, the first issue. When you restart one container for application restart, it will take 0.02 seconds. Means less than 1 second it will take. See how much difference. This is taking less than 1 second and this is taking more than 1 hour. Second one, related to the system response, very high. System response is very high because all the containers, here if the operating system is 6 GB, here the operating system is only 24 MB, 50 MB. Which one will be fast automatically? This one will be fast. So the next important thing is that one, the third one, network will be always maintained bridge networks levels wise. You can create your own networks, and for that networks also you can name your networks, and that networks you can attach to your particular containers and you can run the applications. And the containers when you are running, that you can also specify network wise for the communication of the network, internal networks or internal containers, and you can also maintain your containers naming wise. Everything is, you can do customization over here in the Docker terminology. So see, these many advantages were there in the Docker. So that's why Docker is having a much and very huge market now and forever. So let me simply, this is a concept of Docker, and let me take you to the Amazon AWS console, where we used to create our own servers. So if you click on EC2, so Elastic Cloud Computing, this will provide you the operating system to you. So if you see this one, the first one, you can see the first option is to click launch instance. Creating AWS account steps will be, you can directly search in the net. I also will be providing you the separate dedicated video for this, where you can refer that video and you can Docker is basically, which is a tool like a container shipping from one location to other location. Basically, we are discussing about the concept of like just shipping containers, lightweight containers from one location to other location. That is our main motto. Okay. Good. So next one is launch instances, and here you can select the first one. People who are looking at this one for the first time, creating of launching instances, just note down the steps so that it would be very easy for you to next time when you are going to do practical hands-on labs for you and yourself. I'm selecting Amazon Linux, and after that, the system instance type, I'm just going to choose T2.micro, and after that, I'm going to add the storage as 8 GB. The tags, you can name your tag your server, and then after that configure security group. If you want to deploy any specific application which will serve the port numbers, so for that applications you are supposed to give your customized port numbers which will be you are allowing for your application. So that in that one, basically if we use any dependency on the basis of HTTP, we are going to use that, and HTTPS for the 443, and you can also root 8080 if you are going to use any Jenkins. Maybe in examples I will be using this, that's why I'm adding this one earlier. So basically what happens because of this is, it is going to give you the open your server port for the application serving to customer. So if you keep it as anywhere, people from anywhere of this particular subnet IDs can be accessed. Now you can simply click on launch. Regarding this terminology, everything you can well understand in my AWS classes. No need to worry much about it. Just for now, time you just concentrate on only on creating of the server. Okay, 23/10 is 2021 is the date today. I'm just downloading my key pair, which is an important way. You should download your key pair. This will download your PEM file over here. If you don't have your PEM file, or if you don't have any of your key, then you are not able to log into your system. Means your server. So this is creating a server. So in the download line, you can see the view instances. There it will show you what is your server and where it is creating and everything. You can see I'm just dragging it down. So this is creating. For present, it is in pending state. So now what we will do is we will install the Docker on the top of the system once it is ready. See, now this server is up and running, and now we are supposed to click on connect. One method is we can click on connect here and we can connect. Another method is we can connect through the putty. I'll show that one for the second time. And for now, I'm just opening up here so that I will be connected into my server. See, I'm successfully inside my server. So this is I'm in the dollar symbol represents that I'm in the user mode. If you want to see the username, the Linux command you can give as who am I. I logged in as an EC2-user. But in organizations, whenever you want to apply something, you should have privileges to access all the files so that applications will be installed properly in your system. So to become a root user to get the privileges, we will be running the command called sudo space -i. So that you can see here, if I give the who am I, it will show you the root. So you are the root for the system right now. So let me clear the screen so that it will be very helpful for you to understand. You want to write any, just let me scroll up. I'll give the history of the commands. Note down if you miss anything. Who am I? So what I will do is I'm just going to install, first of all, to install the Docker, what we need is, this is Amazon Linux, so that I'm supposed to use Amazon Linux -extras to get the packages. Install FL is the first option. So this will install the FL packages in the system so that the dependencies for the Docker will be installed. So I'm just hitting enter. So now this is done. And after that, so this is the command I run previously. I'm going to run installing the Docker right away. Just you can give the Docker. So this is going to install our Docker application tool, or you can see as a software as a service in our operating system with the 285 MB of size, it is going to install. And you can see here. So on top of our Amazon Linux server, Docker is getting installed. So now I have the Docker ready. Let me check the service status of Docker. What is in the state? Service name is Docker. This is the Linux command where we use to check the status of an application. Now it is inactive state. You can see here, this is an inactive state and dead mode. So what we have to do is now we have to make this one start. How we can do that one? With using the same service and just you give the start. So what it will do is it is going to start your service. If you want to check afterwards, you start your service. See your service is up and running and it will show active running. Okay. Basically, if you find any issues in starting your service, Docker, inside your server, you can find the errors over here. At present, it is not stating to any error so that your application is working very fine. So basically, if you want to check whether your Docker is working properly or not, and so that we have some special methods so that we can do that one. So before that, what I want to do is I want to chkconfig on for Docker. So that is nothing but to make the Docker auto start process. Whenever you are logged in, automatically the Docker will restart. For that one, what you have to do? You have to do this one. So that symlink will be created. The symlink will be created to tell that one Docker service should be up and running when the system is logged in. So this is also one of the things you do in your real time in the projects. So now let's time for now to check whether the Docker is running perfectly or not. So how we can check? A simple command you can check is Docker run hello-world. This is your first. So first, hold on a second. So I hope you can see the screen. Just a second, I'm going to share my screen. There's some network glitch. So hope you can see the screen right now, right? So here, if you run this command, so basically this command is going to give you the success node. So when it is saying hello from Docker, so basically this is showing that nothing but this message shows that your installation appears that to be working correctly. So in simple words, what I want to say is, so if this image is running successfully is nothing but your Docker installation is appears to be working proper. So likewise, we are going to discuss many of these scenarios inside the Docker. Like we are going to deal with, we are going to deal with Docker basic commands, Docker advanced commands, and Docker components, and Docker file, and writing Docker files for images, and thereafter that using images and customizing images, and after that building containers, modifying containers, pushing the containers to the repository. Then after that, using multiple containers by using the concept of called Docker Compose, and making the cluster availability by using the Docker Swarm. So from 0 to advanced level, we are going to learn in this workshop. So the interested people, now directly you can contact the support from administration, and we will start within next 15 minutes after your enrollment to the class. Thank you. So the payment link is going to be shared in the chat. Once everybody please check and do the payment quickly, and so that you can get the pass to the class. So the payment is around just 2,500 rupees per this workshop. And this class is going to be like till afternoon also will be there, and tomorrow also will be continued. Okay, please confirm me once you're done with your payments.